Mhm.
Here we go. Here we go. Are you ready? COC. Why you dealing with the cyber threat when you know you got an era right? Yeah. You are not alone, don't do it by yourself. Get you some defense will help. If you know you won't be cyber free, come and get you some COC. Satisfying controls, lock them access points. We won't disappoint. COC, fight cyber threats. Promise you will not regret. We go deep and penetrate. COC, come and see.
Hey, hey, hey. Welcome. Yet again, another episode where I forget to take the dang microphone off of mute. It's like, my goodness. Anyway, hey, yeah, today's episode, we're going to focus on the chat GPT, right? This thing that's taken over the world, right? We got to worry about this artificial intelligence. It's what's going to fuel the robots that are taking over our world and all of our jobs and everything that we do. Or is it? Well, we'll see. There's some definitely some very interesting things happening in this space. I can tell you, it was earlier this year. I was at a conference, a space conference, and at the space conference, there were these ghost robotics, and you probably have seen them, but they're like the dogs, right? They're walking around, kind of a thing, and one of the controllers were there, the guys that with the little joysticks and controlling the dog and walking around, and he said, "Would you like me to put it in autonomous mode?" I was like, no, please don't. I don't know if this is a good dog or a bad dog if left to his own devices, right? So I got to worry about those kinds of things. But it's pretty fascinating where this artificial intelligence stuff and all this machine learning and how it's going to materialize into our lives, right? But Chat GPT certainly seems to be, one of the big ones, one of the big winners over the last year or so, produced by the folks at OpenAI, launched in late November of 2022. And by the time January 2023 comes around, right, they're known as the fastest growing consumer software application in history. They gained more than 100 million users in just that short amount of time and had a valuation of $29 billion. So you must be doing something interesting, you get that kind of an attention, right? For sure. Now, when we think about this kind of thing, Chat GPT, and the core kind of a function that's in there is this, and a traditional chat bot is just mimicking human conversation. And but chatbot certainly does, or chat GPT certainly does way more than that, right? It can compose music. It's got, can write essays and fairy tales and answer questions that you have about the universe and those kinds of things, but also write and debug code. And that is what's going to be the focus of today's show. We're going to have a guest on here in a bit, Trevor Sullivan, software developer extraordinaire, and we are going to put ChatGPT to the test, see how it, generates code. And is this code any good, right? Is it code, gold code, or is it code crap? Well, we'll see. We'll take some examples and put it to the test. Now, there's also something called OpenAI, or at least there was OpenAI Codex, and it is an artificial intelligence model that parses natural language and generates code in response. In March of this year, OpenAI shut down access to Codex, but you can still get in the back door there through their OpenAI research access program. Now, that was originally trained on 159 gigabytes of Python code that was extracted from 54 million GitHub repositories. Okay, so they train this thing, understand kind of what's happening with this code and how do you code. And now, the codex was designed to really kind of help accelerate development, software development, and not necessarily as a complete replacement for that and the jobs that are out there, kind of a thing. Um, but it does say, hey, the codex said that they had support for 12 different programming languages that are in there, and but hey, when they did a couple of demos of that, revealed some, maybe some flaws and some inefficient code, some quirks in its coding samples. So OpenAI kind of backed off of that a bit and said, hey, if you're looking for this kind of a capability, go check out, ChatGPT 3.5, right? So ChatGPT 3.5, is out there and it's available to you, and lots of people are using it. But you got to things to consider. ChatGPT is certainly trained on public data, and so as people begin are interacting with it, it continues to kind of learn. And certainly when it comes from from a coding and a technology kind of capability perspective, there are certainly some IP, intellectual property considerations there. There's also some potential for poisoning, right? So you got, in a artificial intelligence engine, a machine learning type of a thing that's being influenced by the data that it's ingesting, and so you've got certainly, some folks out here who, weren't loved enough as children or something like that, and are off poisoning Chat GPT. Now, yes, you got to worry about lots of other things with this artificial intelligence and biases and things like that. And yes, we most certainly see those in Chat GPT. You just gotta really kind of temper that with what kind of information are you trying to get from it, right? If you're you just understand that where it was built and the folks that influence it, there can be a little bit of a bias to be considered there. Okay, so these artificial intelligence, then that infers intelligence. So does Chat GPT have intelligence? Well, in 1950, Alan Turing invented something called the imitation game, otherwise known as the Turing test. And what he proposed is that, okay, look, let's take in a human evaluator and have them judge this natural language conversation that's taking place between a human and a machine. The machine, of course, being designed and to really kind of built to provide these human-like type of responses. The evaluator themselves would know that one of the two is an actual machine. And then the evaluator observes this conversation and tries to determine, okay, can I tell which one of these is a machine? And if they cannot, well, then the machine is ruled as the victor because it has, laid below the radar. It has been able to kind of present itself as a human in that conversation. Well, in December of 2022, ChatGPT became the second chatbot to pass the Turing test. The first one was actually Google's Lambda. That passed the Turing test in summer of 2022. So yeah, we've got a lot of these things are definitely proven to be intelligent, but does it have enough intelligence to write good Rust code? Right? Well, we'll see. We're going to bring on Trevor here in just a minute. Before he jumps on, I want to spend just a little bit of background, painting a little bit of a picture of Rust, the language that we're going to use as part of the test here. Okay, so Rust is a general purpose programming language, and it emphasizes speed. And they themselves, the Rust group, the folks that are kind of running the show from a Rust perspective, say it's blazingly fast. Okay, very memory efficient. All right, and they say that hey, it doesn't have a no runtime or a garbage collector. Okay, well, a garbage collector is a process that comes in behind and cleans up, any unused memory that's in there. Was correct. Rust was created by a software developer by the name of Graydon Hoare in 2009 while he was working at the Mozilla Research. The first stable release was in 2015. And in December of 2022, it became the first language other than C and assembler. Well, that's where my heart lies. Now, I wouldn't be able to code anything in assembler these days, but back in the day, that was the language of choice for myself. But yeah, Rust, became the first language other than C and assembler to be used in the development of the Linux kernel, right? So, yeah, that's kind of a big deal. So, Rust, certainly considered a low level systems programming type of a language, focused on performance, much easier to use. They talk about in developing high performance applications. Higher performance than the ones that are typically developed in C++. So about the same kind of a performance ratio there. The compiler, is a good compiler. You always want a good compiler, but their compiler, identifies any kind of issues in your code before it's even going to kind of build and run it. So we always like that in a compiler. Produces smaller binaries. So we also like that, right? Smaller footprint on our systems. That's always good and healthy. We like that. Useful for building command line interface tools, web APIs, serverless, batch processing, and is friendly with the cloud and integrations on those endpoints. And so that's always good. Extensible. So you can use third-party libraries or what they call crates to be able to kind of do that. It has a large, passionate community with great documentation. And so if your development team is doing automation, you're using Python or a PowerShell, well, you want to consider Rust. And to kind of help you get your journey started, you can head out to Trevor's YouTube channel. He's got 13 plus videos out there on the fundamentals of Rust. You go to youtube.com/Trevor Sullivan. And speaking of which, Trevor, welcome back. Welcome back. I don't think
My turn for the audio issue. I was on mute.
Yeah, there you go.
Thanks for having me.
Yeah, it's great to have you, and I'm super excited about this. It's kind of like, I've thrown some ideas past it in the past. One of the things, applications that I've been kind of working on and off, is a malware de-anonymization type of capability. And so I threw some ideas past it, and it, spit out a whole bunch of code and stuff like that. But then I didn't do anything with that code and try to actually, you see if it was real or not. But yeah, having you here as the Rust expert to put this thing to the test. Any thoughts before we jump into this thing and see how it holds up?
Yeah, well, you did a great job kind of introducing Rust as a language. I started researching Rust probably several months ago, so calling me an expert at Rust is certainly far from the truth. But kind of in an effort to something I've done actually for well over a decade at this point is kind of teaching myself new things by creating content for it. So if I can kind of construct an article to explain something and kind of learn whatever it is that I'm trying to learn as I kind of go through and either write an article or create a video, or at least the outline to create a video, that can kind of help me kind of have short-term objectives that I can work towards in order to learn little pieces of the puzzle. And so that's kind of what I do just on a daily basis is, learn a little more about the Rust language and really just focusing on the fundamentals for now, just kind of what's in the core language, what's in the core standard library. And then, once you get comfortable with that, then you can start kind of going out to the third-party libraries, the crates like you mentioned, and start to kind of bring in some of that external functionality and really start to kind of integrate things together to build whatever kind of application you want to. But yeah, I think the real motivation for learning Rust, especially coming from somebody who's written PowerShell pretty much since it came out in 2006, is really, it boils down to performance. As you mentioned, Rust is a very high performance language, and it compiles into very small binaries, and it scales very quickly. And it does have very close performance to C and C++, if not equal from what I've read. So anybody who's struggling with any kind of performance issues, maybe you're doing ETL jobs or something like that, if you really need to kind of reach for something that's got high performance, Rust is certainly a consideration.
So if I was a developer, if I'm doing PowerShell, this is a natural progression. Are there other languages that lend themselves well for, hey, when you get into the Rust, this is going to make a lot of sense to you, right? Or there's not much of a bridge for you to gap here?
Well, if you're doing high-level languages like PowerShell or Python, there's not really a direct path into Rust. There are some kind of lower-level memory management concepts that you'll want to be familiar with. And if you started out with some of those higher-level languages, a lot of that memory management type of stuff really doesn't even matter from a coding perspective. So in languages like Rust or C++, you have to start kind of thinking more at kind of the CPU and memory level, and be thinking about how memory is being allocated and consumed and then freed up. As you pointed out earlier, Rust does not have a garbage collector because the compiler really aims to catch any memory allocation issues or free issues kind of early stage in the development process. So the Rust compiler is not going to let you compile something that's considered unsafe. You can technically write unsafe code, but you have to specifically put it into an unsafe block. And so you have to kind of know what you're doing in order to exit the memory safety and potentially break something. So it's really nice because it gives developers feedback very early in the process. The error messages are actually extremely helpful to helping you understand more about the language itself. And that's really why I started studying it, is because it's high performance, but it's also easy to write compared to C++.
It's brilliant. It kind of takes me back to you were on the show the first time, and we were, looking at, engineering elements and software development, and we're talking about Kubernetes and the containers. But yeah, if you've got a software development language that is, sensitive to that concept of the containerization, that, hey, I got to protect it, I got to kind of keep this stuff together. I mean, I think that's very, very interesting, to be able to kind of have that built into the language to help protect
Yeah.
yourself from, shooting yourself in the foot, kind of a thing, right?
Yeah, it is a very developer-friendly language. And, kind of tying in with the whole containerization thing, one of the key objectives that we talked about in that very first show that we did is kind of lowering the attack surface of your container images. And one of the ways that you can do that is by removing as many dependencies as possible, and really having kind of a slimmed down container image that has just your application and any things that it specifically needs inside of it. And so because Rust can produce a binary that's a standalone binary and has very minimal dependencies as far as the operating system goes, you can really build these lightweight container images, which improves not only security, but scaling performance. So if you say, hey, I just got a sudden spike of traffic on this particular service, and I need to scale these 100 containers to 500 container instances across a cluster, then Rust is going to scale in a matter of seconds or milliseconds, perhaps even, compared to some other languages that have a little bit more of a startup initialization time.
Wow. That's incredible. Yeah. Yeah. Everything I was reading about it, and when you were talking about it last time, it's like, okay, this is, yeah, no wonder, right? And no wonder you're passionate about it. It sounds like a pretty amazing language. All right. So ChatGPT, let's they didn't give us, for the open AI codex, they made some reference to having 12 languages. They didn't mention Rust there. Of course, don't know how much it really kind of matters, because I don't know how much of the codex is in the Chat GPT in the background, or who knows what. So let's see if this thing has a clue about even Rust is. It may come back and say, I don't know, you need to buff your car or something, get away from the salt. I don't know. All right. So let's see. Let's see if this thing could create a Rust struct that represents a person and has the trait of walking.
Okay. So yeah, let's open up a new chat here and say, I'm a Rust programmer and I want to create a user-defined struct that represents a person.
Yep.
And has a trait of walking, I think you said.
Yep.
Cool. Well, let's see what it spits out here. See if it's any useful here. So it says certainly. That's a good sign.
Yeah, I like its confidence.
It is kind of cool. I mean, I've used it to kind of as like a Google alternative. I kind of like to think of it as it's a little bit more of a direct response than what Google gives you, but a lot of the same information. Obviously, I'm sure they're harvesting a lot of the same resources as Google to train this model. But let's see what we've got here. So we've got a Rust trait. I mean, these are pretty simple definitions. A trait basically just represents behaviors. It's not the implementation of a specific behavior, but it just declares what the behavior is. So it's declared a method called walk here. It created a person struct with 2 fields. So we have a name field. So just a first name, presumably not a last name field, which you would typically have. We've got an age here. And then we have a implementation for that walking trait for the person struct here. So that basically links the trait right up here that has this method declaration on it to the person type. And so the implementation of that walk method basically just prints out a line that says person's name is walking. So these little curly braces here are substituting self.name, self.name being the person's name field here. And then here in the main method, or the main function, which is the entry point to your Rust program, it just instantiates the struct right here, and then it assigns the struct instance to a variable called person, and then it calls that walk method on the person instance. So why don't we just copy this code? There's actually a little copy code button there, so I don't even have to select it. And I've already got VS Code set up right here. So the way I have VS Code set up, just for a little bit of reference here, is, and I actually go over this in my video series, which I have right here. It's a Rust programming tutorial playlist that's got 13 videos so far, but the very first video that I did several weeks ago was on installing the Rust toolchain on a headless Linux server. So I just use Ubuntu Linux server. It just runs SSH. Actually, I don't even think I SSH into it. I think I just use LXD to get an interactive shell and install whatever I need to on it. But then I use Microsoft Visual Studio Code here to remotely connect to that Linux server. So down here in the bottom left, if you can see, there's a pink box that says SSH Rust. So I guess I did set up SSH, but basically VS Code, this window right here, is connected to that remote Linux server. So even though I'm on a Windows client system here, I actually do my development work for Rust on a Linux VM that runs on one of my LXD bare metal hosts. So that allows me to just spin up and spin down infrastructure as I need to. So what I'm going to do is typically I put projects into a Git folder. So right now I just have this Rust programming folder here. So if I do cargo new and we say person-walk, that'll create a new cargo binary application. And then let's open that up in our editor here. So we'll go to Git and then our project folder here. And so what cargo new does is it basically spins up a new project. There's two types of cargo projects you can create. One's basically just an application that you can run at the CLI, and the other is a library type. So if you're creating functionality that you want other developers to plug into, you can just create a library type. But if you're creating a CLI tool like what we're doing here, then it's just an application type. So we'll just paste in that code because it already declares the main method down here. And we don't have any dependencies that we need to declare at the top of our main.rs file here. All we have is the trait, the struct, the implementation for the trait on the person struct, and then our main entry point. So I'm not going to make any other code changes to that. I'm just going to save main.rs, and then we'll do cargo run, which basically tells the cargo package manager to execute. And sure enough, down here, it prints out this line, Alice is walking, from line 15 here.
All right.
So it worked.
So where did it come up with Alice?
Good question. I wonder if we ran it again. So it just hard coded that right here on line 21. But I wonder if we
okay. Oh, they hard
again.
coded it. Okay. I was gonna I was like, okay, is that part of the AI? It's just making up names along the way.
I guess the Rust compiler's talking to AI in the back end, right?
Okay, right. Okay, so that's...
Should we try running it again?
Yeah, sure. Let's see
if
what
it
we
gets
got.
A different name. I don't know if it will or not, but we'll see. Kind of takes a while to generate here, but anyway, I guess we could talk about the next one if you want.
Yeah. Well, I'm just,
Oh, we got Alice again.
Oh, we got Alice. Okay. So they like Alice and Bob, right? So that's our, those are very popular in the IT
well,
and cybersecurity.
Then what they can, sorry. I was going to say, then what they could do is go to the person struct and add a location here, and they could make it Alice in Wonderland, right?
Exactly. Okay. All right. So that's impressive. So let's see if we can do something here. How about create a Rust for loop that iterates over an array of people's first names and prints it out to the console.
All right, what do we got here? So I'm going to go ahead and create a new project here. We'll do a maker. What is this one? Print first names. And let's open that up in our editor here. Print first names. And let's just do cargo init here to build out our structure. And we'll go to our main.rs file. Let's see what it gives us. Well, it did wrap it in a main function, so we can literally just copy that once again and overwrite our default main function. So right here, it looks like it generated a array of string pointer values. So Rust has a couple of different string types. There's string pointers that are the default that allocate on the stack. And then there's another type of string that allocates on the heap, which looks like this capital string. instead of a string pointer. So they're using an array of string pointers right here, which is what that ampersand means. And then down here, they create an iterator, and then they just print out the name for each person. So pretty straightforward code here.
All right.
And there we go. Alice.
There we go. There's Alice and Bob. I was telling you, Alice and Bob, yeah, very popular in our crypto scenarios when we talk about that. Okay, well, hey, it's off to a good start. That's pretty impressive. Let's see. Create a Rust iterator that uses the map function to add bacon to the end of each string.
All right, let's see what we get here. So we'll probably have some kind of array or vec again. Yeah, they used a vec this time. So they're creating a vector type of string pointers with a few values in there. Let baconized foods, that's a nice variable name, equal foods iter. And then here's this part. So this is the part that we really wanted, is using this map function, which basically mutates these strings up here. So it just starts with the first element, goes to the next inside the for loop, or actually inside of the map function here. And then this right here, it kind of looks weird if you don't know the syntax for Rust, but this is what's called a closure in Rust. It's basically an anonymous function, and food in between the pipe characters here is an input argument. And then you have a function body that isn't surrounded in curly braces here. So basically everything in between these outer parentheses is what's called a closure in Rust. And that's going to run for each element in this vec right up here. And then down here, after it performs the transformation using map, it just runs a for loop over the values inside of that vec and then prints it out. So hopefully we'll have apple bacon, banana bacon, and carrot bacon. I actually have a video that's dedicated to closures as part of my playlist, and they can be a little bit confusing, especially if you're not like primarily a software developer. You know, if you're kind of DevOps type role and coding isn't part of your full-time job, you know, some more advanced programming concepts may not come clearly. But this video right here, Understanding Rust Closures, aka anonymous functions, that covers exactly that process. So let's do a new folder here. I just like to create new projects for all my things just so I don't get lost. And I guess I should have just made one though. So then we'll do cargo new food bacon. Let's open that up in our editor here. I gotta say, I love the ability to connect to VS Code remotely over SSH. It's just amazing to be able to do all my development locally, rendered locally, but actually running on a Linux VM. It's amazing. So let's go to main RS, overwrite our main function that's been scaffolded out by cargo, and then we'll just do a cargo run in this folder, and there you go. Apple bacon, banana bacon, and carrot bacon. I've never had carrot bacon. Have you, Jeff?
I have not. Yeah, not high in my list either, let me tell you.
Nah.
Maple, yeah, and they got that $1 million bacon now, you know, that they just, yeah, they threw all kinds of stuff on it. Okay, so that's, yeah. All right. What about maybe showing example of generating, I would say 10 people with first and last name fields.
I'm trying to remember if I even prompted it for Rust last time. Oh yeah, I did. I said Rust iterator. For some reason, because I think it picks up on some of the context, and so even if I hadn't specified Rust, I feel like it probably still would have given me Rust.
Well, it has the memory of the conversation, so I think it's kind of assuming, well, they asked me about Rust before, I'm going to stick with it and see how it works out, and if he doesn't like it, then he'll let me know, I'm guessing.
And I think in the very first prompt up here, I said I'm a Rust programmer, so that kind of gave it some like broad context about my profile or who I am.
Yeah. Yeah, that's interesting. Yeah.
I haven't really tried that. I try to be as explicit as possible because I want a correct answer most of the time. But
Right.
I guess it would be an interesting exercise to kind of leave out some of that context intentionally and see what it gives you back.
Yeah. Yeah. Well, and I was kind of thinking, well, what if I set the tone? I said, I'm a new Rust programmer, right?
Mm.
And is it going to elaborate? Is it going to put comments in my code, right? So
Mhm.
I can read it and go, oh, well, that's where that's at, right? Um, you know, that would be interesting to see if it goes to that level. And
And if you say you're an expert programmer in Rust, then it
yeah,
just leaves the comments
yeah,
out, right?
yeah, it leaves everything exactly. It leaves everything out. You should know this. Right?
Well, it looks like we got a beginner answer here because we do have comments. But
Aha!
there's Alice again and Bob.
There she is.
So we've got a person struct. I think the person struct before just had a name and an age field. It didn't even have distance walked. So it implemented the walk method, but it didn't have a distance walked property to keep track of how far you walked. So that was a
Yeah.
little interesting. But this one has first and last name as the only fields.
Yeah.
And then we have two arrays. One array contains the first names, one array contains the last names. Then we iterate across all the first names and we zip them together with last names. So I actually just did a video earlier today and I just published it maybe 2 hours ago on some of the iteration functions that are available in Rust. And I went through a bunch of examples. It's like a 55-minute video and it goes through a bunch of examples of the different iterator methods that are available. And there are some really cool methods that just help you to work with arrays of data of many different types. And one of the functions that I actually went over in that video was this zip function here, because what it does is it takes an initial array like this, where we just have just the first names, right? We just have this one-dimensional array. And then we have another one-dimensional array that has last names. And if you want to combine each of the first names and each of the last names together, assuming that you have the equal number of elements in each array, then you can zip them together. And that's what this is doing right here. So if you think about what a zipper looks like, it starts on one side, then it goes on the other side, then it goes on the other side. If you look at a zipper, it's alternating I don't know what you call them, but the little divots that stick out from the zipper. And that's exactly what the zip function in Rust does across an iterator. So it'll go to Alice, it'll take Alice, and then it'll combine it with Anderson. And it'll give you back as a result what's known as a tuple data type. And in this case, it actually looks like they're constructing the person instance here, but normally zip would just give you a tuple if you didn't use this map here to then construct a person from that data. But it's really cool because it basically will just take one value from each of these, mash it together, and that's your result. It's pretty cool. I really like it.
So is it are you seeing stuff in the code that you're like, okay, that's unusual or that's different or I wasn't expecting that or anything like
this is
that? Or
actually
is
very straightforward.
it's pretty straightforward? Okay.
Yeah, this vec type here. So this part right here is really what's doing most of the logic here. I know it looks kind of long and maybe a little bit confusing, but basically if you just kind of break it down, we're starting with just first names, right? So we go to first names and we say, all right, grab Alice, put Alice into the pipeline here. So we iterate across Alice and we say, all right, I want you to zip with last names. So when we tell it to zip with last names, it starts with Alice and then it grabs the first last name. It mashes that together into a tuple where you have basically two values that don't have a data structure. There's no field name associated with it. You just have a 0 entry and a 1 entry.
Yeah.
And so you don't have a first name and last name. You just have 0 and 1. And so that then zip does that for all of the elements here. So you'd have Alice Anderson, Bob Brown, Charlie Clark, and so on and so forth.
And it's creating a data element from as a that's what the output is it's actually taking those just arbitrary 0 and 1 values and saying, I've got something and I'm going to name it this, and this is what the value of that is. Yeah, brilliant.
Yep.
Okay.
And then it gives you that tuple data type that it doesn't have any field names. It's just 0 and 1 are the indices to access each of those values. So 0 would be Alice, 1 would be Anderson. And then on the next one, 0 would be Bob, 1 would be Brown, and so on. But then after it zips up all of those things into these tuples, these pairs of values, then it takes the first and last name from that tuple and it actually constructs a person object using the constructor for the struct that was declared right up here. So then it passes in these variables. So it's basically taking 0 and 1 and mapping first and last to it. And then we pass these values as inputs to this closure again. See those pipe characters? That kind of indicates that we're dealing with a closure here, which is an anonymous function. And this statement right here, literally all it does is for each element in the pipeline, it constructs a new person and then returns it back.
Yeah.
So
brilliant.
after it's constructed all of those persons, then it returns something called a map object. And if you look at the documentation for iterators in Rust, there's a special map type that gets returned when you call the map function. So what you need to do if you want just a regular vec, a vec is basically like a resizable array with a generic data type. So in order to turn the map object into the final vec of person here, you have to call this method called collect, which turns the map object into a collection. And then by using this what they call a type annotation, where we're basically telling the compiler what type of collection we want to, for lack of a better term, cast the map into, it's finally going to assign this vec of person, array of person, to this variable called people. And so now we've got something that looks somewhat similar to this, although this is an array, not a vec, but it's basically got these person objects inside of it rather than just standalone string values.
Yeah, right. Yeah, okay. Yeah, I like that.
And then finally, the last thing is once we've aggregated all those first and last names together, it just does a simple for each loop, and there is no each keyword in Rust. It's just for in. But then you do .iter, which gives you access to all the interesting iterator methods that I was talking about earlier. And it simply prints a line that says first name, colon, and then a placeholder, and then last name, colon, placeholder. This is what's called your format string. And then these values over here get substituted for each of these placeholders. So the person.first name would go here, and the person.last name would just go there. So, I mean, that's pretty much a perfect example.
All right, brilliant. So the code looks good, but does it work?
Does it compile?
Does it compile? Yeah.
Let's create our Git folder here. cd git, make dir 10 people. Is that right? Yeah. From arrays. I don't know. That works for now. And then we'll open that up in here. Oh, I got to do my cargo init too. So if you don't have a folder created yet, you can do cargo new. But if you already have a folder that's empty that you want to create a project in, you just do cargo init. And that just uses the current folder, which apparently it doesn't like because it has a number at the beginning. I haven't actually done that before. So what I'm going to do, just to speed things up here, is use Vim. So let's go into one of our other projects that we've already created, like, how about food, bacon? We already saw that one work. So we'll just do Vim source main.rs. We'll do 55dd to delete all that, and then we'll paste in this code. So if we go back to, I was already in our root folder because I did Vim to the subfolder. So we'll do cargo run, and there we go. Alice Anderson, Bob Brown, et cetera, et cetera. Pretty straightforward, and it compiles.
Yeah. Charlie, okay, yeah, first name, last name. Yeah, it's brilliant. Okay, all right.
So it actually matched up the first letters. Do you see that? So the first and last names actually have matching letters for all these names. Right. I didn't even realize that until just now.
Oh, yeah, that's clever. Wow. Okay. Okay. I'm impressed. So yeah, man, I think, yeah, we'll do some more examples, but I'm just thinking I can come up with 1,000 other ideas on how we could take stuff generated from here. And then there's another, there's a plugin called Code Igniter. And what it does is it does data analysis, right? So we come in here, we get it to write some interesting code for us to go generate a nice huge data set, and then we throw that data set into Code Igniter and see if it can produce any kind of intelligent analysis of the data. That would be kind of cool to do that. All right, let's see. Show an example of using Rust to generate 100 UUIDs and write them to separate files.
Generate 100 UUIDs and write them to separate, I'll just say text files. All right, let's see what we get here. So in this case, we need the UUID crate, which is a third-party component. If you head over to crates.io, this is the package registry for Rust. So if we did a search for UUID, this right here is the package that it's referring to. Pretty well supported library to just generate unique identifiers. And yeah, it's been updated as recently as about a month ago. So
oh, nice. Okay.
That looks good. One thing I do notice though is that in the dependencies here, so we have this file is part of our Rust project called cargo.toml. This is basically your equivalent of something like in a Node.js project, you have package.json. In other types of projects, you might have, what is the C# XML project file called? CS_proj file, I think. And then, in Python, if you use Poetry, there's the package manager called Poetry. There's like a project.toml file or something like that for your dependency management. And so in this case here, it's basically telling us to add this dependency in our cargo.toml file. And what I did notice here is that the version of this dependency is pretty far out of date. And I think because ChatGPT was only trained up through, let's see, I think it was only trained up through 2021, if I recall.
Yeah,
and
exactly.
So if we go back to 0.8.0, is it? It just says 0.8, so I'm not sure. Maybe that's this one here. But yeah, this was 2019, 2021. Oh yeah, look at that.
So that could be problematic.
Yeah, and that's not to say that it couldn't work. I mean, we could certainly give it a try, but there are quite a few newer versions compared to that. So let's just try the one that it suggests here and see what happens. So let's actually just open this up in our editor here because I love using the VS Code editor. So we're in the Food Bacon project. Ignore the project name because we're obviously doing something else here.
Yeah, we're optimizing. Yeah, reuse.
So learning as we go. So in cargo.toml, this is generated by cargo init or cargo new. And down here under the dependencies section, we'll just paste that in, remove that duplicate header. And then for our code file here, we declare the external crate that we're going to be importing. We import the UUID. I think that's a struct. I'd have to look at the docs for it. Or maybe it even tells me right here. Yeah, so we import the UUID struct. And then we use a for loop to generate 100 UUIDs with this method here called new v4. Then we use file create, which is part of the standard library in Rust, to create a file reference. And then we call the write all method to write the data to the file. And then it tells us that we should have a text file for each of those UUIDs. Well, let's see what happens. All right, so as we can see here, we do get a compiler error here. It says no function or associated item named new v4.
Oh.
So if I try to run this, we are going to get that error. Now, what's going on?
What's going on is that's not a result of the crate, is it?
Well, crates in Rust have this concept known as features. So they're basically these optional features that you can install. And if we take a look at the features for 0.8.2 here, I'm not sure if they list them in here. But yeah, see how there's a declaration example right here to activate various features, use this syntax.
Yeah.
And one of the features that they're activating right here in this example is this v4 feature.
Oh,
So that's not installed by default unless you specify that you explicitly want that particular feature in Rust.
okay. So we got to go back and we need to make a change there, huh?
Yeah. So in cargo.toml, we'll just paste in the syntax here, specify that we want these other features, and then back to main.rs here. And yeah, even the Rust Analyzer extension for VS Code, even before we compiled it, was already able to detect that that's now available. So now if we just do cargo run again, it should compile just fine. All right, okay. So it prints out a little debug message here to show us that it's writing 2 files. And if we open up our folder here, check it out. We've got a lot of text files here that have UUIDs. That's kind of interesting.
Yeah.
So if you're writing, database records or something and you need a unique identifier, that's how you can generate one.
Yeah, that was quick and easy, right? Yeah, brilliant.
So a little hiccup there, but that's only because it's a little bit out of date, and for whatever reason, it didn't understand how to use features in cargo.toml. Not really sure why that is.
Well, yeah, I mean, for folks that are doing this, and you can imagine you're going to run into similar kind of issues with other libraries or things that you're pulling into your code. Yeah, you got to consider that, right? That this thing's a little dated, right? And so you might have to do a little bit of legwork to kind of get some of this stuff to tweak to work exactly like you want. But so far, looking pretty good. Frankly,
yeah.
I'm very impressed.
Yeah.
Do you have any ideas, any stuff that you want to throw at it to see if you can break this thing, or just see how smart is it? Right.
Well, maybe we could try generating a web API.
Yeah, let's get it to do something like next level.
All right. So what do you want the web API to do?
It's going to go out and pull something down, or what's it going to?
Well, I don't know. We
something
probably shouldn't
for
create
me,
any
or
external dependencies, because that could break something. Well, I mean, that's kind of our intent.
Yeah, that's our intent. What can we have it do? Have it go out and, let's say, scrape. Okay, yeah, that works. I was going to say scrape the word "the" off a given URL, but yeah, list of restaurants. Let's do it. Let's see what it can generate.
And menu items and prices, and return them as JSON objects. Also expose a REST API endpoint that allows creation of new restaurants and menu items. Anything else?
Do we want to put any boundaries around it? Limit geography, or location data, or type of restaurants? Arizona. Okay, let's do Arizona.
Mexican restaurants.
Mexican restaurants. All right.
Include alcohol menu.
Yeah, and is open in 7 minutes, or will be open in 7 minutes. All
right. Let's see what we get here. There's a bunch of different web API crates out there, so I'm not sure which one it'll use. Oh, Warp. I was going to guess that maybe it was going to use one called Axum. There's a pretty popular library out there called Axum for Rust right here. And I actually just created a sample application the other day with Axum, and it worked pretty well. Pretty popular project, 12K stars. But let's see about Warp. I'm not sure how many stars we've got. 8.4.
Okay.
Nice. All right, so we've got Tokyo here. All right, so Tokyo is something you're going to come across a lot in Rust. This is basically an asynchronous library, and if you're doing pretty much anything asynchronous, you're probably going to end up using Tokyo. There are some alternatives, but this seems to be kind of the mainstream one. And then, of course, Warp, that's the web framework. And then Serde is basically this generic framework that allows you to translate objects in Rust, like a person instance or a dog instance or whatever kind of data structure it is that you define. You can kind of translate those data structures to different serialization formats like JSON or YAML or XML or Parquet or things like that. So that's what the Serde library is used for. I'm actually planning on doing a video on that sometime in the near future once I start getting into third-party crates. So that's the dependencies here. Let's go ahead and grab those and bring them in. Oops, I don't know what I'm doing here. Screen's turning to mush. Let's go to cargo.toml. We'll get rid of UUID because we don't need that anymore. And save that. And then as far as our code goes, did it stick everything in one file? Looks like it did.
Yeah.
So let's just try to copy that. Do we have a main function? Yep, there we go, async main. And then this attribute right here, typically when you're doing async stuff in Rust, you're going to come across this attribute that applies to the main function. Normally, if you don't have Tokio or some other async execution library, you can't do an async main function. But if you import one of these third-party async libraries, it lets you do an async main function. So let's copy that and bring that back in to main.rs. See if we get any warnings from our linter here. It's doing a cargo check command. And I'm not seeing any problems show up in VS Code. It's still running here, though. Kind of excited if this actually works.
Yeah.
I haven't even looked at what kind of information it inserted in there, but looks like we've got menu items with a name and a price. All right, good enough. Could probably add some kind of category like, breakfast, lunch, dinner, dessert, that kind of thing. But alcohol menu items, same thing, name and price. And I will note, actually, so for the price, it did use a floating point value because we don't want integers. We don't want whole numbers. I mean, we're getting that direction with inflation and everything, but, we might get rid of our pennies and cents someday. But for now, we have pennies, sub-dollar values. So it is using a floating point value for that, which is good. So you can do like $2.43 or something. And then for the restaurant here, we've got name. We've got a menu with a vec of menu item and an alcohol menu as a separate field with a vec of alcohol menu items. Sweet. And then we have these this derive attribute here, and this has something to do with the Serde library, but it's basically saying that this data structure can be serialized or deserialized by the Serde library. So that's what allows it to translate our custom structs in Rust to JSON and back. All right, so the big question is, what are our endpoints here? So it looks like it's declaring an endpoint here called get restaurants. So basically /restaurants on the API, and then it's going to return restaurants. And where's restaurants coming from? Oh, it's right up here. So we have a vec of restaurant, and then the menu items are child objects of that, and then the alcohol are child objects of that field there. So it's basically like one big object that's been kind of stuck together with child structs here. But it looks like we're getting a warning here. So it says expected a closure that implements the clone trait right up here. So apparently one of the data types that are being used in here, a vec type, needs to be implemented. So it says it's implemented for vec restaurant pointers, but it's not implemented for mutable pointers to restaurant, which basically means that a mutable variable just means that you can mutate the values inside of it. So if you wanted to change the name of the restaurant, it would allow you to mutate that field value. But for some reason, I guess it just didn't implement that particular trait on a mutable instance of a restaurant. And so that's breaking this right here and preventing us from actually instantiating new restaurants. So we did break it.
Woohoo! We did it. Yay!
Just for sanity, let's just do a cargo run and just confirm that the compiler does in fact give us that exception there. I'm not sure which exactly, but one of the libraries that we imported up here is declaring a whole bunch of child dependencies. I don't know if it's Warp or Tokyo or Surdy, but one of those has some transitive dependencies that we're pulling down here.
Man, this ain't gonna compile.
It's just compiling the dependencies now, so probably not. Yeah.
Okay, there we go.
Yeah. So probably wouldn't be too hard to fix, but you know, can't really do that on air.
That's right. That's right. I'm impressed that it wrote code that actually compiled and worked. Okay. We threw it, definitely a curveball.
If we change the implementation to Axum instead of Warp.
Oh, okay. So maybe, see how much control.
Just curious if it'll, it says certainly, so it knows what we're talking about.
Okay. Well, then maybe that one's going to work out a little bit better.
There we go. Cargo.toml has Axum, but not Warp. So let's try to update our dependencies. Ooh, Axum 0.3. I think that's pretty old. Let's find out on crates.io. Go to Axum. Yeah, we're up to 0.6.20. And, oh man.
Yeah,
that's pretty old. Well, that's actually not too bad.
What is it, 2021?
Late 2021. So let's take a look at the code, though. So Axum handler for post and get operations. That's actually what I like about Axum is its data types are pretty sensible from what I've seen so far. Certainly not an expert with it, but yeah, let's just paste this in and see if it throws any issues here. So Rust Analyzer is going to have to go through our dependencies, probably do cargo check. I saved the file. Do your thing. Let's just do a cargo run. And wait for compilation. You know, that's like one of the only downsides with Rust is that compilation times are a little bit slower than other languages. Like Golang is notorious for compiling extremely fast, which is really nice. But, I think Rust has a little bit of an edge on performance at the end. I mean, post-compilation, like execution. All right, so no get in handler, no post in handler. Unresolved imports. Is that because it didn't declare the crate up top? No, it knows about router. Huh. We broke it again.
Yes. I get some sick joy out of that, They're good, but hey, there are limitations, right? So it's good to know, right? Good to know, all right?
Yeah.
But all things considered, even, if you were an experienced Rust developer, at least you'd have a fighting chance, right? You'd have something to start with instead of starting this thing from scratch, and hopefully the debug is a lot faster than having to generate yourself. So
yeah, it's always important. I think one of the things I wanted to mention on the show is I just wanted to emphasize that AI is not a substitute for understanding the fundamentals of a language, because this is the kind of stuff you're going to run into if you depend heavily on AI. I've seen posts out on Reddit where people are like, oh, I'm going to, you have a PowerShell script generated that does a bunch of stuff for me in Active Directory. I'm like, you might want to think twice about that, dude, before you go off and run some code that generates.
Exactly. Yeah, just take that code. It's good. Yeah, no, you can totally trust it. Right? It's like,
hey, Joey, why are there 1,000 users missing from Active Directory? Any idea? Because the audit logs say that you deleted them.
Right. Exactly. Exactly. Well, there was, along that same topic, there was an attorney that, as part of the court case, went and used ChatGPT as part of their arguments, right? And then went to court and tried to use it. And half the stuff that ChatGPT made up like court cases that didn't exist. Right. And this attorney is going in and saying, well, and according to, Jones v. whatever. And it's like, ChatGPT just kind of made it up. So, yeah. So probably better that, you leave that coding examples and then utilization to the professionals, right? Otherwise, you end up, clearing out your AD, and that would not be good. So,
I mean, by all means, I use ChatGPT periodically. I still use Google primarily to do my learning, but once in a while, sometimes I like the format, the little bit more directness of the response that ChatGPT gives me. But again, I have to remember that these are out-of-date libraries. So if it tells me to use Axum just like here, I can't really depend on that. I have to look at the Axum documentation to really understand how to use the current versions of it due to breaking changes in the API between different versions. So, conceptually, it's great. I like the idea. I think one of the ideas that I'd like to see more development on in the future, though, is, locally self-hosted AI where I can actually train my own custom model on my code set. So I can point it to my Git server, say, hey, go clone all these repositories, look at the code, and basically learn from what I'm doing. And then that's a lot more tailored to my experience writing PowerShell or Rust versus what some out-of-date model is doing. So
yeah, brilliant. Well, hey, Trevor, it's been amazing. I truly appreciate you going through, and that was fun. I was like, I've always wondered how good that code is, and so now we know some of it's good, maybe not so much the other stuff, right? And yes, tread lightly. Don't just copy and paste and use this code because you don't know what it's. If you don't understand the code, then you don't know what you're kind of getting yourself into. So
start with the fundamentals, and I mean, you got to put in the time. There's no shortcuts in the world, and you got to put in the time to understand what the code's doing. I mean, you can paste in this code in main.rs here, but if somebody says, hey, I want you to add this feature, and you paste some code in another file, can you really explain what's happening?
Right.
I don't think so.
Yeah. You want web content? Okay, fine. Right. Yeah. You get all the words you write. At least hopefully you can understand the written language. Okay. We'll give you that much. But but definitely proofread it. Exactly. Yeah. Or you'll end up like that attorney. Yeah. In big trouble. Yeah. All right. Brilliant. Thank you again, Trevor. It's as always been amazing. That was really enjoyable. Everyone else, we'll see you tomorrow night. Take care.
See ya.
Now you know you're feeling better.